Section 6.2 homework, we're going to use StatCrunch again, the built-in calculator tool. Okay, assume adults have an IQ score, normally distributed, mean 105, standard deviation 20. Find the probability that a randomly selected adult has an IQ less than 125. Okay, so mean 105, standard deviation 20. Less than 125. Get more help. Open StatCrunch. Stat calculators. Normal. Okay. In section 6.1, we were using z-scores, which is called the standard normal, that have a mean of 0 and a standard deviation of 1. Okay, we've got to change that because this time we have a mean of 105, a standard deviation of 20, and find the probability that it's less than 125. Compute. Okay, 0.8413. 0.8413. Okay. All right, this time it's IQ scores with a mean of 97.7, standard deviation 22.3. Find the probability that an adult has an IQ greater than 125.1. Okay, so let's go back to StatCrunch. What happened to my StatCrunch? Okay, stat calculators. Normal. Mean of 97.7. Standard deviation 22.3. It said greater, so we're going to change it to greater. Greater than 125.1. 0.109. Okay, the 5 has a 9 after it, so that 5 goes to a 6. Okay, mean of 105, standard deviation 20, IQ between 95 and 115. Okay, so we need to change it to between. Said mean 105, standard deviation 20, between 95 and 115. Compute 0.3829. Okay, now what we're going to do is we're going to find an actual value instead of finding a probability. Okay, so engineers want to design seats in an airplane so that they are wide enough to fit 90% of all males. Okay, so it said accommodating 100% would make them too wide, so they're going to fit 90%. Men have a hip breadth normally distributed with a mean 14.2 inches, standard deviation of 1.1. Okay. Find the hip breadth that separates the smallest 90% from the largest 10%. Okay, so the smallest 90% would mean 90% is less. Okay, the smallest 90% would mean that 90% of men, their hip breadth would be less than this, okay, which means they could fit in it, fit in the seat. Okay, so we need stack crunch again. Okay, this time we need to go back to standard. Okay, the mean was 14.2, standard deviation 1.1. We want 90% to be less. Okay, so we need to find the x value. We need to find an area of 0.90 to the left. Okay, 0.90 is 90%. So this would give us 90% the value of hip breadth. It's a hard word to say. Where 90% would be smaller. Okay, 90% of men, their hip breadth would accommodate this. Okay, so that's 15.6097. I forgot to see the decimal places. Round to 1. Okay, so that would be 15.6. Okay. Adults have an IQ score normally distributed of mean 103.7, standard deviation 19.9. Find the first quartile, which means 25% is less. Okay. The first quartile would mean 25%. Quartiles mean divided into 4 places. So 25% would be less. Okay, so we're looking for the actual IQ score. Okay, so we're going to change our mean and our standard deviation. Okay, we're doing less than. Quartile means that percent is less, but quartile means 0.25% is the area. Okay, what's on the right side of the equal sign represents the area in the curve. We're trying to find the actual value. Okay, 90.277. 1 decimal place, 90.3. Okay, what that means is 25% of people have an IQ less than 90.3. Okay, now this one says find the mean and standard deviation. Okay, so we're going to use the data table. Now, that's a lot of numbers, so what we're going to do is click Open in StatCrunch. Stat calculators. Or no, sorry, summary statistics. Columns. Select variable 1. Okay, it's okay if we do all of these things. Let's just less clicking. Okay, so what is our mean? Now I'm going to write down all of these numbers. 71.783333. Standard deviation 12.137027. Okay. Verify that they have a distribution that's normally distributed. Okay, I should have read the whole question. I could have had this done. Open in StatCrunch. So we want to graph a histogram of variable 1. Okay, see how it sort of forms a bell curve? Okay, mostly looks like a bell curve, where most of it's in the middle and then it tapers off at the ends. What that means is most of the data is here in the middle, and the further you go away from the average, the less likely that's going to happen. Okay. All right, so we saw that it does look like a normal distribution. All right, the mean round to 1 decimal place was 71.8. Standard deviation rounded to 1 place was 12.1. Okay. The pulse rates are normal because the histogram looks like a bell and it was symmetric. Symmetric means roughly the same on both sides. Okay, treating the unrounded variables, okay, that means use all those decimals. Assume that pulse rates are normally distributed. Find the pulse rate separating the lowest 2.5% and the highest 2.5%. Okay. Now I'm going to do both of these at the same time. Okay, using the calculator. So if 2.5% is on the left and 2.5% is on the right, that means 2.5 plus 2.5 equals 5%. So that means the ends are 5%. That means 95% is in the middle. Okay, so 2.5% are the lower values. 2.5% are the upper values. 2.5 plus 2.5 equals 5. So that means those two things make up 5. So that means 100 minus 5 equals 95 is in the middle. Okay, so I'm going to find the middle 95%. Okay, now if you don't have two screens, writing these things down on some paper really helps. Okay, so 71.78. I'm going to put in a bunch of 3s. Okay, it said the unrounded values, which means put all those decimal places it gave you. Okay, I'm looking for these values that it's in between. The area that I know is 0.95. Okay, so that tells me my lower value is 47.9952. The upper value is 95.5715. Okay, so the lower value is 47 point, what are we rounding to? 1 place. All right, so that 0.9 means that's going to go to 48. Okay, the upper value was 95.57, so that's going to go to 95.6. Okay, and that's the end of our homework.